Welcome to the Lesson 8 quiz, and we'll go ahead and get started. Number 1, which of the following soil types are unacceptable for the support of a building? And we'll just go down the list. Number 1, compacted fill. That is acceptable. Number 2, fine grained soil. That can be acceptable. Number 3, organic soil. That is unacceptable. And I don't know if you guys have a garden, but if you ever have a garden, I do, and I know when I rototill it and put compost down and go in there and till it up, and if you do what you need to do, that's a lot of organics in there. It's good for growing plants and whatnot and for crops. But when you step on it, I know after I'm done, I'll go back and I'll, be pulling weeds or picking strawberries or picking asparagus, and I go in there and I will sink down like 6 to 8 inches just on that organic soil. So number 3 is definitely unacceptable, so that'd be one of our answers. And then let's look at number 4. Number 4 is unconsolidated fill. And that is also another instance that is unacceptable. You need to compacted that fill, because if you go in, it will have the same type of effect as organics. Probably not as bad. I don't know, it could be. But it's still unacceptable. And if you need to go back and read the beginning of this chapter, I think that will get you where you need to be. So the answer to number 1 is 3 and 4, which is letter D, 3 and 4. All right, number 2. What type of foundation is generally square in plan with the reinforcing steel near its bottom face? So it's square in plan. That takes away typically a cantilever footing, a mat footing, a strap footing. The only logical one that I take from this question would be B, a single column footing. And go ahead and just take a look at the diagrams that they have in the study guide and just get a general idea of the purpose for each type of footing, and that should be self-explanatory. Number 3, what do we attempt to do to minimize? What do we attempt to minimize in designing building foundations? So what are we attempting to minimize when we're designing building foundations? 1, bending moment. Well, bending moment in the footing? Sure. I guess. I don't think that's where that question is getting at, but 1 is kind of a yes, but not really. It's not really the best answer, I'm guessing. Number 2, differential settlement. Yes, that's a good answer. We are definitely attempting to minimize differential settlement. Shear, that's the same thing as bending moment. Well, yeah, but that's not kind of the point. We're going to make what works. The number of test borings. What do we attempt to minimize in design? Well, you want to minimize test borings, but really test borings, the reason you test bore is to get a better idea of what type of soil you have so you can use a smaller safety factor. So the best answer by far is B. And remember, you want to minimize differential settlement and just plain old settlement. Because, for instance, let's take a look at a simple frame here, and here's where they originally are, and differential settlement. One side will settle down this much. So what is that going to do? That's going to induce weird moments in here. And let me think. That's going to want to go that way, and this will probably bend out that way. This is not perfect by any ways, and I may be wrong in my diagram, but it'll be something like that. The point is, it's going to induce moments that weren't there because of any other load, just because of the changed shape of that frame or that column or anything. The fact is, you don't want differential settlement. And I think they said something about that's why you want to make sure that the bearing pressure over here and the allowable bearing pressure over here that you're designing for are pretty much the same. Then that means it won't settle differentially. All right. Let's move on here. Number 4. What test procedure often forms the basis for determination of a soil's bearing capacity? What test or procedure? Number 1 is compaction test. Number 2, or A is compaction test, 2 is Proctor test, 3 is seismic exploration, and D is the test boring. And the answer to this is test boring, D. And if you want, go look at page 141 and look over and justify that to yourself. Like the Proctor test is for optimum moisture content, I believe, and seismic exploration. You know what? I'm not even sure. I typically don't do seismic exploration. Maybe to find voids or whatnot. But look into that yourself. I would look at page 141 and kind of read that section again. On to number 5. Select correct statements about pile foundations. Number 1, timber piles are not treated with preservatives unless they are permanently below the water table. I think that's opposite. Yes, it is. Timber piles, if they are permanently below the water table, then they don't have to be treated. If they're not, then they do, because the water kind of protects them from any bugs or rot or anything like that. Alright, so that's not an answer, 1. Number 2, drilled piles transmit their load to the soil by skin friction. That is correct. Belled caissons transmit. Drilled piles, yeah, that's correct. Belled caissons transmit their load to the soil by end bearing. That's also correct. We did an example for both 2 and 3, so both of those are correct. Let's move on to 4. Wood piles have a capacity of 30 to 50 tons and are usually end bearing. And I don't think that is true. I remember taking a look and reading real quick through here, and it said that typically wood piles are skin friction. Let me figure out where that is real quick. I guess you can read through this as quickly as I can, so I probably should just say okay. Give me 2 seconds. Tell you what, if I'm finding it in 5 seconds, then I will say it, and if I can't, I'll just move on. 5, 4, oh, there it is. Alright, timber piles must be treated with creosote or a similar preservative unless they are permanently below the water table. They are usually round in cross-section, 20 to 40 feet long, with a capacity of 30 to 50 tons. So everything sounds correct right now, which they support by skin friction. So that is why 4 is incorrect. They said they are usually end bearing. They can be end bearing, but right here it says skin friction. So we're going to assume that that is correct, and number 4 is incorrect. Then we will move on. Number 5. Through extensive use in field testing, pile driving formulas have proven to be very accurate. That is incorrect, and I remember seeing that. You go over to page 151, and you can see on the right side, underneath the equation there, P equals 2WH over S plus 1, experience has shown that pile driving formulas are not always accurate. So 5 is incorrect. So the answer is 2 and 3, which 2 and 3 correlates to B. Okay, moving on to number 6. Hopefully we can get this done. We'll see. Single column footings. A are stressed and tension. Single column are stress and tension in the top face and compression in the bottom face. So it's saying, here's a single column footing looking at an elevation. Let's go ahead and do that. And it says, are stressed and tension in the top face. Nah, that's incorrect. Because remember, the soil is going to be bearing on it like so, and therefore it's going to deflect like that. Obviously not that much, but I'm just overstating it to show my point. So it's going to be compression and tension in the bottom face. So A is incorrect. B are designed as assemble beams. Incorrect. They are designed as cantilever beams is how I always look at them, as I look at a cantilever and see what the max moment is right at the face. And I think it also goes over that in the on page around 146, 140. Oh yeah, you can look at it on the diagram. Actually, it says moment on page 147. It says load area shown hatched, and it's moment. So you're going to want to look at it, cut it right here, and just look at it right there, and what's going to be your moment, assuming this is fixed. All right. So that's incorrect. And as are designed as simple beams, we said that was incorrect. C, are never governed by shear capacity. Never governed. That's incorrect. Always those nevers are very, very hard to agree with. So since it says never, I say no, that's wrong, because there are going to be some instances where it will be governed by shear capacity. D, which we're going to assume it's D, but it says have flexural reinforcing in two directions in the bottom face. Yes, because if you look at it, you're going to have the moment right here and the moment right here. So if you look at it where you load right here, you're going to have a moment, so you're going to have reinforcing going this way to combat that. Resist that is probably a better term if you want to be an engineer. Alright, and then you're also going to have to look at it right like that with that face, and the reinforcing will have to be like so. So that is correct, like we assumed, and the answer is D. Whoops, I erased a little bit. That's okay. Let's go back, actually. That may bother me. Alright, moving on. We have 7, number 7. Let's turn the page, and it says, for number 7, two 18-inch square columns are located as shown below. Column A supports 200 kips, so let's just go ahead and draw it real quick. You have B, oh, it looks exactly like that other one that we did. You have A, these are the center line of the columns. It looks like the center line of columns are 20 foot. Please excuse my drawing, but it's on this tablet, which is probably not the easiest. I need to figure out a better way to do this stuff. And then you have the property line, which is 3 foot, which is a little bit different than what we had. For example, it was 2 foot. And this is our property line. Let's go ahead and call it out. Alright, and it says our column A, so let's put it over here, equals 200 kips. And column B is 245 kips. And the allowable soil bearing pressure is 4 KSF. Let's do ALL, OW, allow. And you'll know allow bearing. Try not to confuse you. And that is 4 KSF, I think I said. Neglecting the weight of the columns, determine the size of a combined rectangular footing. Assume the footing weight to be 40 kips. So we want to do exactly what we did last time. You want to think of it as a fulcrum. Or where is the fulcrum? Where is the middle point? You want to make the middle of this footing the middle of these loads. Maybe I can use better terminology there. The resultant of those loads, let's say that. And you know what? I'm going to center this so it's a little less confusing. It's easier to picture when it's somewhat to scale. Alright, so using in our head, if we did it right down the middle, this is 245 kips. This is 200 kips. And actually, I have run out of time, so I will continue number 7, 8, 9, and 10 on the next video for Lesson 8 quiz part 2. Alright, see you then.